In this video, I'm going to talk about how you can facilitate the summary conversation for Unit 7, Day 21, Lesson 11b, What are perfect squares? The focus question of this lesson is how do perfect squares make some quadratic equations easier to solve? So if I go down to the explore portion of the lesson, students are first asked to compare two different methods. Han's method, which is using the traditional zero product property strategy to solve a quadratic equation, and then you have Jada's method where perfect squares are used to solve the equation. Students look at these two methods and describe what each person did at each step and begin to think about which method they prefer. Our goal in this lesson is to get students exposed to this new way of solving quadratic equations using perfect squares, and for them to see how much simpler it is to use this strategy as opposed to the strategy they've been using when they're approached with a perfect square quadratic equation. And so students are then asked to solve these quadratic equations. They're asked to solve them using Han's method and solve two using Jada's method. So I have this lesson on Desmos, and actually let me just go to the actual lesson. And the lesson is a little bit different on Desmos than it is on this platform because each question is split up into an individual slide. And students are asked on slide 14 to solve this one. X plus 4 raised to the second power equals 9. And they're asked to choose which method to use, Han's or Jada's. On slide 15, students are then asked to show how they solve the previous problem using Han's or Jada's method and state which method they used. And so here's the space for them to do that. So I went ahead and screenshotted two student works, and I actually put them both on the same slide. And so we have one student that used Han's method. Sorry, let me remember the two methods. We have one student that used Han's method and one that used Jada. So here's Han's method. And here's Jada's method. And on the slide, it asks students to actually go ahead and write which method they use. If students don't write the method, you can ask which method was used here, which method was used here. This method was Jada's, this method was Han's. Okay. And so then we have this question that's going to allow students to really synthesize their thinking of this lesson. What do you notice about these two strategies? Which do you prefer and why? So what do you notice? I noticed for Jada's method, the first step is to find the square root of both sides. I noticed for Jada's method that the square rooting the both sides cancels out the squared value. I noticed for Jada's method, when you square root a number, you have a positive and a negative value. I noticed that both of them have the same two solutions, -1 and -7. I noticed for Han's method, there's a lot more steps to take. I noticed for Han's method, I have to set the equation equal to 0. Why? Because in order to use the zero product property, we need to be multiplying two values to equal 0. I noticed for Han's method, I have to multiply binomials, and then I also have to factor. So I have to do kind of these two big steps within solving the equation. Those are some of the key things students might reach out and say. You might ask, what are some mistakes someone might make when using Jada's method? Well, they might forget that there's two answers when you square root 9, a positive and a negative. They might forget to square root the 9. What are some misconceptions or mistakes students might make here? They might make a calculation error. They might make an error when factoring. Again, students might not find two solutions. Students might forget that they have to set this equal to 0, and they might say the answer is -4 and is -4. They might not remember to use the zero product property. And then so all of that is part of the conversation, pointing out those key ideas around the misconceptions and around just how much simpler this is, and emphasizing the idea that you are having two solutions no matter what method you use. And then giving students a chance to voice which method they prefer. Students might still prefer this method because it's more familiar to them. That's okay. We're going to continue working with the perfect square method, and students might begin to shift over to using that method when they are able to use it to solve a quadratic equation. Students might prefer this because it has less steps. It's easier not to make a mistake. It's a simpler method. It's faster. Students might, again, and then students will most likely prefer this because they're more familiar with it. It feels like, they might say, it feels easier to me. It feels like I could do that method faster. It feels like it's less likely to make a mistake because I already know how to do that. Giving them that space to answer that question is going to further solidify their understanding. When you're asking students to share what they notice, you can just choose to start out with, what do you notice about Jada's method? Let me just clear that off. And then you can go back and ask them to just share out what they notice about Hans's method. So you can focus in on one strategy at a time. Okay, so in summary, students, it's really important to give students a chance to look through one another's work and solidify their understanding of the lesson by having this conversation about the differences between the strategies, the notice things about the strategies, and which method they prefer and why.